In this video, we'll be looking at inverse trig relations. We know that the sine of 30 degrees is 1/2. But the thing is, we can talk about this vector as an angle of 390 by just taking a rotation around and stopping at the same place. So we can also say that the sine of 390 is 1/2. And then if we take 2 revolutions around and stop at the same vector, we can say that the sine of 750 is also 1/2. And this can continue. Likewise, we can draw our reference triangle in quadrant 2 with a 30-degree reference angle. And in this case, we can say that the sine of 150 is also 1/2. Remember, 150 we got because we have to take 180 minus the 30-degree reference angle. Now if we do a rotation around and stop at this vector, we can also say that the sine of 510 is 1/2. And then if we do 2 rotations and stop at that same vector, we can say that the sine of 870 is 1/2. And this goes on also. Now notice these angles we got by taking 360 added to 150. That'll give us the 510. And if we add 360 to the 510, that gives us the 870. Same way up here, if we added 360, that's a complete revolution, to the 30, we get 390. And if we add 360 to the 390, we'll get 750. So we get a number of angles that all have a sine of 1/2. So in all of these examples, we know the angle, and we want to find the ratio. So now when we talk about inverse trig relations, we know the trig ratio, and wish to find the angle. To designate an inverse trig relation, we use arcsine 1/2 equals, or you might see this notation, which is the inverse function notation. So this says the angle whose sine is 1/2 is equal to something. This one also, the angle whose sine is 1/2 is equal to some angle. So we want to read this, or at least think it, as the angle whose sine is 1/2 is. So whenever you're dealing with inverse trig relations, you know the trig ratio, and that'll be the argument of your inverse trig function or relation. So using what we had up here then, we can do the inverse trig relation and state that arcsine 1/2 will be 30, 390, 750, and so on, or 150, 510, 870, and so on. So knowing that my trig ratio is 1/2, then the arcsine, or the angle whose sine is 1/2, will be any of these angles. Since this gives an infinite number of answers to the question arcsine 1/2 equals what? This is an inverse relation. Not an inverse function. So to indicate that we have a relation and not a function, we will use arcsine of some ratio, or you might see this notation, some ratio. We will use arc cosine of some ratio. Let me write ratio here because it's not the R value. Or we might see this notation. And then arctangent of some ratio. Or this notation. So if we were to evaluate arctan of 1 over root 3, we know that the tangent is positive in quadrant 1 and also in quadrant 3. Tangent is defined as opposite over adjacent. So my opposite side is 1, and my adjacent side is root 3. And we're looking for the angle, so let's call it theta. So let's do quadrant 1 first. This angle is going to be a 30. So arctan 1 over root 3 is equal to 30. And then if we do a complete revolution, adding 360 onto this, we have 390. And then adding 360 onto this, we have 750. And so on. Then we also need to give the angles in quadrant 3. Again, my reference angle will be a 30 because I have a -1 and a negative root 3 as my adjacent side. So my angle would be, this is 180 plus 30 is 210. I left my degree measure off. 210 and add 360 onto that. We have 570. And add 360 onto that. We have 930. So these would be my arctan 1 over root 3.